Okay, I'm not going to do question A because it's not on the course anymore, but all you have to do is work out the gradient of MAB and the gradient of MBC and say the gradients are the same, B is a midpoint, therefore it's collinear. That's all you're doing. So the gradient of this bit, gradient of this bit, and then say, yep, the two gradients are the same, they share the B as a midpoint, as a common point, therefore it's collinear. Nice and easy. I'm going to do the next bit, which is determine the equation of a circle with centre D. So the first thing with all these, and actually they've been quite nice, they've given you the centres, so you don't have to work them out from anything, is to do a nice sketch and a label up. Okay, so I think I'm gonna, yeah, it's gonna be a bit busy, but I'll put that in there. So it's -7, -2, just to get everything onto your diagram, because otherwise it's very easy to get muddled up, make a small mistake. 17 and 6. Okay, so that's my centres. Yep. So I don't need to know any of this anymore. That's all fine. The next bit is to do the radii. So the radius of A is √10. Okay, so I know that this whole distance here then, right, that's going to be 2 √10, isn't it? √10 plus √10. And this says that the radius of B is twice the radius of A. Okay, so if it was √10 before, that means this radius is now 2 √10. Yeah, it's twice the radius, yeah? So that means this whole distance here is going to be 4 √10. And this one's saying that the radius is RA plus RB. Okay, so that's √10 plus 2 √10. So this one is going to be 3 √10, which would make that whole distance 6 √10. Very good. So it means the diameter of this circle, and in fact, before I do that, so I've labelled everything up, okay? And if I'm trying to get the equation I wanted? Yeah, the equation. To get the equation, I need to do the centre, I need to do the radius, and from that I can then write down my equation, which I'll put in this form, because that's the kind of the nice easy form, isn't it? X squared, y squared. And this bit here is the r squared value, which I will substitute in. So I think now I can have a look at the radius, can't I? Because I know the diameter of the circle is 12 √10. Yeah. So the diameter is 12 √10. So the radius has to be half that. So it's going to be 6 √10. So in my little equation, I can then say, okay, well the radius, 6 √10 squared, yeah, that's going to be 36 times 10. So that's going to be 360. 6 times 6 is 36, √10 times √10, yeah. So that's not bad. That's me halfway to getting some marks. All I need to do now is think about the centre. Right, so the centre. For this, you're going to be wanting to do a little bit of Pythagoras. So I know that A is -7, -2. I might actually want a bit more space for this. I'll see how we go. So A is -7, -2. And I know that C is 17.6. And this is very similar, every question, very, very similar. So how far have I gone horizontally and vertically? Well, I've gone 24 horizontally, that way, and vertically I've gone 8. And I have travelled on that distance, I have travelled, let's have a look, 1, 2, 3, 4, 5. I've travelled 5 √10s, haven't I? 5 √10s. So it's just the distance from, if I know that's right, that was to D, sorry, that was to D. So no, not 5 √10s. 1, 2, 3, 4, 5, 6 is 8 √10s, sorry, 8 √10s. Okay, travelled 8. Now if I want to do 1 √10, so I want to just factor that, I want to change that. If I only wanted to move 1 √10, I have to just divide everything by 8. So suddenly my 8 becomes 1, and my 24 becomes 3. Okay? All I've done here is divide everything by 8. It's a bit like, if you look at this distance from A to C, okay, if A to C is doing this, right, that's my 8 √10. I have just looked at doing this in eighths. 2, 3, 4, 5, 6, 7, or so I'll leave it on 8. Okay? So I'm looking at one of these steps, okay? I said that the whole thing itself, I do the whole big thing, I said the whole thing was 24 and 8, but I just want one little step, which is 1 and 3. And that's my root 10. So now I can say, right, well, the centre from D relative to A, if I start on A, I need to go 1, 2, 3, 4, 5 of those root 10s. 5 of them. So let's draw that out again. So if I start on -7, -2, I need to go 5 root 10s. So I'm going to times everything by 5. So this triangle here, I'll times all that by 5. So 1 becomes 5 and 3 becomes 15. So now if I add on those, I'm going to have my final centre. So in the x direction, I'm going to add on 15. So if I add on 7, I get to 0, then I'm going to add on 8. And -2 add 5 is going to give me 3. So it means that this value D is 8, 3. So I'll just change the signs, -8, -3, -8, -3. And that's us finished. Now, when you actually think about it, look how little working there is there for 4 marks. It's actually not a lot. And when you think of your skills, what was the skill? It was doing Pythagoras. So in a way, it's quite easy. But in another way, it's a wee bit tricky and footery, and it does require a wee bit of practice. But if you can do this, and there's similar questions to this in the Zeta textbook and in the higher website, if you can do this question, you know, that's as hard as they can make it. Also, like I said, the collinear thing's out this year, which is very similar to there's vectors is out as well. But I think the collinear thing's out. I think so, but the vectors is definitely out. And this is actually quite vectorish, so you might find that this question a bit easier this year, 2023 with vectors been out, but don't quote me on that. But yeah, you're basically doing some Pythagoras, and you're making sure you've got your C, R, E, so that even just the radius, you know, that was worth a mark to get the 6 root 10. And getting the centre, you know, that was worth effectively 2 marks, and then your final answer in the right form, you know. So I'm not sure how it would have worked if you just made up a centre here and did this. I'm not sure you did it too, but anyway, get a sketch is the most important thing, and just, you know, crossing these off and populating the drawing, really important, and just knowing to work in those little triangles. To me, if you do that, you know, it makes it so much easier. It's very visual what's going on. Okay, some people like to do it with ratios and things. That's fine. You can do it that way. I quite like to just do it this way, and then imagine what is one step. You know, how many steps have I got? Get 8. What's 1 then? Okay, I'm going to go 5 steps to get to, you know, to that. To me, that's nice and visual, and it's very easy to not make a silly mistake or get things muddled up. Okay. So I hope that was helpful.